Today we're going to be moving on to session 3. We're still going to be working on our part-whole model, but today we're going to be looking at taking those equations off of our model. Okay, so our mission again is constructing tape diagrams so that we can understand those word problems on our grade level and be able to solve those. I want to show you that today I am actually offering a little something extra, a little engagement strategy. I'm going to be choosing a class of the week at each grade level based on how well you're paying attention and completing your exit tickets. So if you become one of those classes, you're going to get to scratch off the board for a prize, okay? So make sure that you're working really hard today so that you're able to complete that exit ticket to the best of your ability. All right, let's take a look first of all. We've got some tape diagrams here. And this one's got 2 parts we see. And notice that in this first one, our whole is missing. And in the second one, we have a part missing. We know we need to add here. Notice though that since my tape diagram only has 2 parts, all I have to do is take those 2 parts and add them together to make the whole. I only have to do one operation or one step. The same thing with subtraction. I know my whole. I have to pull out 8 and then I'm going to pull down that remaining piece because we always pull from our whole. And I only have to subtract one time. 10 minus 8. That one step gets me the answer. I want you to keep that in mind. When we've got 2 parts, only 2 parts, then we only need to do one step, one operation. Look what happens though when we end up with 3 or more parts. In this top problem, I'm missing the whole, so I know I need to add my parts together. Now I know these are very simple numbers, so we can probably do these mentally, but typically when we've got larger numbers, we will put our first 2 parts together and then we will add the third part. So that's 2 steps. Notice when I have 3 parts or more, I'm going to need to do a minimum of 2 steps to solve it. Same thing, especially down here when we're missing a part. Take a look, we've got a 3-part problem here. I've got to pull out 6, pull out 4, and then I'll be left with that last part, which is my answer, right? To solve this problem though, what we would do is we take the parts that we know and put them together. So we would take 6 and 4 and put them together to make 10. Then we would look at that whole of 12 and we would pull out that 10 that we know so that we could find out what was left. So notice, first we add, and then we subtract from our whole. So again, we have to do 2 steps. So keep that in mind. If I've only got 2 parts, I only need to do 1 step. But if I have 3 parts or more, I'm going to be doing a minimum of 2 steps to solve it. All right? Because today we're going to be doing some things a little bit more challenging. You're going to notice now that the thinking is going to start happening. Our last couple weeks we've been doing a lot of moving with counters. Now we're going to start getting to that abstract thinking. Okay, so let's take a look at our first problem. And we've got our hands ready because remember guys, the modeling with our hands part is very important to help us to understand that problem and act it out. So do this part with me. Okay, here we go. Ramai had a collection of blank sports cards. Okay, we know he's got sports cards. We don't know if we're pulling from them or if we're going to add to them yet. We have to read our next sentence first. So we've got those sports cards in our hands and it says, blank of those cards were football cards. So some of the cards that are in my hand are football cards. So I'm going to pull those out. So here's my football cards. The rest were baseball cards. So that missing part is going to be the baseball cards. How many baseball cards did he have? So notice we pulled from that first number. So whatever is in that first number, whatever's underneath that first box is our whole because we always pull from our whole. So let's see what number we're going to write in our whole today. 29. So everyone, just like I'm doing, I need you to write 29 in your whole. Today, though, we're going to also baby step our equation. So take a look at the bottom. I believe you have a little equation box at the bottom of your tape diagram mat. And if you don't, you can just create the equation at the bottom. So since we're starting with 29, we're going to baby step that equation, and we're going to actually write 29. Okay? Now, we know that he's got 29 cards. Let's see how many of those cards are football cards. 12 of them are football cards. So in my tape diagram, I am going to pull down 12. I'm pulling from that hole. So everybody else is writing their 12 under our football cards. Now go over to your equation and we're going to pull. Let's see, what would our pulling symbol be? Our pulling operation be? If I am pulling from my hole, I am going to subtract. I even like to think of that subtraction symbol as a pulling symbol. Like I even will sometimes draw the little arrow showing that I'm pulling from that 29. Okay, so we are pulling from that 29 and we are left with the rest. We've got that unknown there in the rest. So let's see, how will we draw that in our equation? We pulled out our 12 and we are left with the rest. Go ahead and put your equation. We just baby stepped through our tape diagram to create our equation here. All right, we've got that written down. Now let's see, how do we solve? Well, let's go back to what we know. We are missing a part. And since we're missing a part, we always subtract. So I'm going to take that 12, I'm just going to rewrite it vertically because I know I'm subtracting. And I am left with 9 minus 2 gives me 7. 2 tens minus 1 10 gives me 1. So I know that n equals 17, or the number I was left with, baseball cards were 17. Okay? Now let me show you. You can go ahead and wipe your board super quickly. But this next piece might be one of the most important parts of our whole lesson, so be sure that you're paying attention here. So I've got a list of equations here. We don't have any model, we don't have any word problem, and I want you to be able to tell me where the parts are in each equation and where the whole is. So let's see if we can figure out what's missing based on where our unknown is. And I'm going to use this little part whole tape diagram finder to help me figure this out. Remember how we talked about when we've got two parts, this line helps us know that we need to put those parts together or add, right? So I'm going to go ahead and lump all this together and I'm going to show you how I can use this part whole model to help me figure out if I'm going to be adding or subtracting. So let's look at this first one, 12 plus 18. It's a pretty easy one. We'll start with, look at that. I know my two parts. I can see them right there. So I need to put them together to find my unknown, my n. So to solve this equation, I would need to add, right? Let's look at this next one. I'm going to go ahead and put my part whole. I know those plus signs tell me those are my two parts. So look, do I know both of those parts? I don't. My unknown is inside of one of my parts. If I'm missing a part, I subtract. So I need to put that over here. How would I subtract in this problem? Remember, we always subtract from our whole. Which one of these numbers is our whole? 30 is our whole, right? Because we know 12 is our other part. I can see it right there because I'm putting it together with n. So I would need to do 30 minus 12 to solve that problem. Let's look at the next one. There's my plus sign. There's my two parts. Again, look, I am missing one of my parts. So I would do subtraction, right? 30 minus 18 would give me that missing part. I would pull from my 30. So there's another subtraction problem. Even though we don't see a subtraction symbol in there, we know we would have to subtract because we're missing a part. Look at this next one. Oh, wait a minute. That's a subtraction symbol. So I can't put my plus sign over the top of it. how would I show this on my part whole tape diagram? Well, look, I have N and I am pulling 12. That's my pulling symbol. So if I am pulling from the 12, then that means this N must be my whole, because we always pull from the whole. That subtraction symbol always points me to wherever my whole is. My whole is right here because I am pulling from it. So since I am pulling from that whole, I know that this one I must be adding, because if we're missing the whole, like I am, I have to add. So I put 12 and 18 together. Now this last one, this is the trickiest one. Again, I can't do this because I've got a subtraction symbol. So where is my whole? I want you all to think about it. Which one of those is my whole? And say it. N is my whole because I am pulling from that N. So I'm missing the whole. If we're missing the whole, we add. That means we know our two parts. So something that might have been a little confusing before, hopefully this will help you know how to add those equations and put those together or take those numbers apart. Moving into a little more challenging territory, now we've got 3 parts. So let's take a look. Let's start with our hands. Mario scored blank points in the basketball games he played last week. So here's all the points in the games that he played when? Last week. Okay, let's see if this is a part or a whole that's in our hands under that first box by reading our next sentence. He made most of those points, so we're going to be pulling most of those points in his first game. He scored some points, though, in his second game and some points in his third game. So that first number is our whole because we are sorting all of the points he made from each of those games. So let's take a look. What are we going to write in our whole? We've got 14 points. So everybody put your 14 in your whole, just like I did. We're going to baby step our equation in just a moment. I want to get our model filled out first, since this one is a little bit more challenging, okay? He made most of those 14 points in his first game. So I'm going to pull out most. Wait a minute. How many is most? We don't know, right? That is unknown to us. So go ahead and pull out your unknown. He also scored 4 points in the second game. So from those 14, we are going to pull out 4 points. You do the same thing. And how many points did he score in the third game? 2. So we're going to pull down 2 points. Okay. Now, we've got our model ready. Let's take a look at our equation. Now we know we do part plus part plus part to give us whole, right? So I went ahead and did that for you down here, but I don't want you to write this yet. I wrote N plus 4, and I know that's a plus sign because we always put our parts together. That's what that line reminds me of. Plus 2 equals 14. So there's my equation. But that equation doesn't exactly match my problem, because if you remember, the problem started off by talking about the 14 points. So since the problem started off talking about the 14 points, then my equation needs to show that. So how can I rearrange this equation? But to start with the 14, it would look like this, and you're going to write this with me on your boards. 14 equals N plus 4 plus 2. Now it matches our actual problem, okay? So we wanted to start with that 14. And we can do that. We can put that whole at the front of our equation or the back of our equation. That equal sign tells me I can actually move it on either side. Okay, so now that we've got our equation written correctly, let's take a look. So we've got our 14 points that's we started with, and here it is in our tape diagram, and then we've got it here. So we see it's first, right there on top and first, and then we put all of those parts together in the exact same order that they are in the problem. How do we solve this though? Let's take a look. Again, we talked about if we've got 3 parts, we know we're going to need to do at least 2 steps. So when we know that we're missing a part, we do need to subtract ultimately. But before we can even subtract, we're going to take the parts we know and put them together, combine them to make a super part. And to know that we have to do that step first, we want to be sure and include parentheses in our equation. I like to think of those parentheses as almost your hands going, do this first. So we're going to do that step first. Make sure you put your parentheses. And when we do that step first, 4 plus 2, that gives us a total of 6. And you can see how I've just kind of revised my model to show you what we've actually done is combine those 2 parts that we knew. And that's that first step right there. And we now have a new equation of 14 equals n plus 6. Now I'm ready to solve. So let's see. I've made this now just a 2-part problem, so I can use my little part whole finder. There's my plus sign, so those are my 2 parts. What am I missing, a part or a whole? My unknown is in my part, so I need to subtract 6. All right, so 14 minus 6 would give me a total of 8. N equals 8 in this problem, or he made 8 points in his first game. Okay, so notice with that 3 parts, we put 2 parts together, then we either add or subtract that 3rd part depending on what we are missing, our part or our whole. Just one little quick reminder, you got to be making sure you're working hard today, because today's exit ticket, I'm going to ask you to figure out an equation and make it match your story. So make sure you're paying close attention. We've got one more that we're going to do, practice together, and then we're going to do 2 more different things today. So let's take a look. We're going to model with our hands first. Jack sold blank books. All right, we got books in our hands. He also sold several magazines. Several. That means the same thing as some. So I don't really know what that is. That's my unknown. My magazines is going to be my unknown. So he sold books, he sold magazines, and he sold decks of cards. So we've got 1, 2, 3 parts this time. He sold blank items total. So whatever's underneath that items box, that's our whole. So we've got part, whole. Let's go ahead and model it now. He sold 7 books. Okay, everybody do your 7 books, just like I'm doing. He sold several magazines. Remember, several means some. So I don't know how many that is. So that's our unknown. And he sold 2 decks of cards. So we slide in that 2. And that's for a total of 13 items. Now take a look, guys, because there's something a little different here. I've got my 3 parts, but notice how my N is right in the middle of them. Let's go ahead and look at our equation. If we started off with 7 books, that's the first part of our equation, plus he sold some magazines, so do you know what's next? Plus N magazines, plus 2 decks of cards. Well, there's that line, so I know I need a plus sign, 2 decks of cards. And it gave him a total of 13 items, so we're going to write equals 13 items. There's our equation, right? Here's the tricky part though. Remember, Ms. Purser told you before that when we've got 3 parts, we need to do 2 steps. And that first step is to combine the parts that we know. Well, and I like to use parentheses to do that, right? To show whoever is looking at my work that I combined those 2 parts first. Well, my problem is I can't put my parentheses like this because now n is stuck inside of there and I don't want that. Luckily, I know because of the commutative property of addition, I can rearrange my parts just like this. And it still will equal the same thing. It doesn't change my answer, right? So I'm going to rearrange those parts, and now here is my new equation. Does everybody see what I did there? Now we're ready to solve. 7 plus 2, we're doing that first, that gives us 9. So my new equation is now 9 plus n. Now, what am I missing, part or whole? Here's my plus sign, so I know these must be my parts. I am missing a part. So to find that answer, I need to subtract. 13 minus 9 gives me 4. So he sold 4 magazines. We always look back up at our problem to make sure that we know what it is that we're counting and what we're trying to answer. 4 magazines. Now, this one's going to be a little more challenging. Get ready. I've got some equations here, and we're going to look to see if we can figure out if the unknown is representing a part or a whole. So let's look at this first one. Again, I think our first one's a little bit easy. If I've got my 3 parts, look at that. What am I missing? I'm missing a part because my unknown is in the part. And since I'm missing a part, I would combine the parts that I know and then subtract them from 20. Let's look at this next one. What's missing? A part. So I would combine the parts that I know and subtract them from 20. What's missing here? Where's my unknown this time? It's in the whole. So I would combine 2 parts and then add that 3rd part to find my whole. This one gets tricky, guys. Take a look. I can't slide it like this because I can't go over a subtraction symbol with an addition symbol. I can tell, though, that this n, this unknown, must be my whole because look at that symbol. I am pulling from it. So if that n is my whole, look where my 3 parts actually are this time. There they are. My 3 parts are 7, 4, and 9 because I'm pulling from my whole of n. Okay, let's look at this last one. This is your most challenging. Where are the parts and where are the wholes? Well, I can tell 7 and 4 are parts. That one's pretty easy because I have that addition symbol right there. What about these 2 pieces? Some kids think 9 would be the whole just because it's over here on by the equal sign by itself. But it's not. Look at this symbol. We always pull from our whole. And in this equation, we are pulling from n. N is my whole. So even though this 9 is not over here next to these other parts, it's actually a part. So pay very close attention. When you see that subtraction symbol, you know it is pulling from our whole. And since our whole is missing, when the whole is missing, what do? We add. Okay. Here's the part of my favorite part of the lesson. On this lesson, this part of the lesson, I'm going to ask you to tell the story. I'm going to give you the model, and teachers, if you'd like your students to work with a partner, this is a great opportunity for them to do that. I'm going to pull out a character and a setting, and I'm going to show you the numbers, and you are going to tell a math story that matches these numbers. So you can do this either in your head or you can share this with a partner. We're going to go step by step through it. Here we go. So let's do monkeys and on trampolines. So this is what our word problem is going to be about. Monkeys on a trampoline. Here we go. We're going to start here with 12. Tell your partner something with 12, with monkeys and a trampoline. Okay, let's see. That you may have come up with something like this. There were 12 monkeys jumping on a trampoline. Okay, get ready. Something's going to happen. Let's see. Miss Purser is pulling. So think about in your head, what symbol is that? Am I adding or subtracting? There were 12 monkeys on a trampoline. Something's going to happen with 4. Ready? Tell your partner. Okay, if you need more time, pause. Let's take a look. You may have said something like 4 of them did backflips. Okay, here's our next part. Here we go. And tell your partner. You may have said that some of them fell off. And our last part, tell your partner. You may have said 2 just sat and got bounced around. Okay, so now it's time to come up with our question. Think back to what you said here. Like Miss Purser said, there were 12 monkeys, 4 did backflips, some fell off, and 2 just sat down and got bounced around. So here was my ones that fell off. So my question needs to be about my unknown. How many monkeys fell off? Now you come up with your question. Okay, so guys, can we come up with the equation we would have written for this problem? We would have said 12 equals 4 plus n plus 2. Okay, there's other equations that also would have worked. You may have said 12 minus 4 minus n equals 2. That would have been another option. And then to solve it, we would put together the parts that we know and then pull that bigger part from 12 to get our answer. Okay, today's exit ticket, you have a problem that you're going to have to baby step the equation, and you also are going to read a problem and choose the equation that matches that problem. Good luck today, and I will be announcing the classes of the week once I see your exit tickets. So do your very, very best on the exit ticket, and you will have the chance to win a prize. Have a great day, Mathletes.